Practice exercise 88. I want to show you some things that will make your life easier on the calculator. So practice exercise 88. Quick refresher for you from your junior high days. The circumference of a circle, C equals pi d, the diameter of a circle. That ratio of circumference to diameter is pi. That's what defines pi, besides tasty dessert. Also, you could find it 2 pi r because, of course, 2 radii equals a diameter. So either way. Circumference doesn't use squared units or anything like that. Remember, it's just a distance around the circle. But when you were in junior high, you used 3.14 for pi, correct? But you know it's not 3.14. It's 3.141592. And it just keeps going literally infinitely, never stops. It's irrational. Well, your calculator has pi in it. Most of your calculators, it'll be up here on the left-hand side. Raise your hand if you need help finding your pi button.
I don't think I ever learned this.
It's okay. Of course not. I'm teaching them now.
I mean circumference.
Okay, well, I'm sorry about that. Pi. It's got to be on here somewhere. Pi. Where did you go? You're kidding me. A scientific calculator without a pi key?
Tough.
It's got to be on here.
Is it the second part?
Oh, there it is. Yeah. Okay, I finally found it. It's down at the bottom. Right here above this, so it'll be the shift. So shift gives you pi. Okay? All right, and all the rest of you have an actual button that's really super easy to use. Okay. So for instance, if I gave you a diameter of 10 inches, the circumference being pi times diameter, you would simply hit the pi button times 10. And what is the circumference of a circle? And it just keeps going and going and going. But you'll notice the directions for exercise 88 say round to the nearest hundredth. How many decimal places is hundredths? 2 decimal places. Your calculator can do the rounding for you. So you don't even have to think. Well, let's see. 2 decimal places, 5. Does that bump it up? Yeah, it bumps it up. 31.42 inches. But you could do that on your own. That's not that hard. But when you have 8 problems, you all have to round to the same anyway. Why not let the calculator do it for you? So if you look down, most of you, at the bottom of the calculator, you see your decimal button, and above the decimal it says fix. This allows you to fix the calculator to a certain number of decimal places. So what you want to do is hit second function, because fix is in green on most of your calculators, and when you hit the fix, nothing happens, then hit the number 2. And you notice it rounds to 2 decimal places. It will continue rounding to 2 decimal places until you turn the calculator off or take the fix off, which for now we're just going to leave it there, and I'll show you at the end of the lesson how to change the fix. But second, fix, and you tell it how many decimal places you want, in your case, 2. Audrey, let me see if I can help you figure out how to fix your calculator to a certain number of decimal places. Yours is round, right here on and D. So shift, round, and you want to round to 2 decimal places. Maybe that's not what it is. Well, you know what? I'm just going to let you do it in your head. It's not that hard anyway, and I'm not sure. It should have been one of these buttons down here, so if it's not that, maybe this one. No, it's not. Okay, so you just have to round in your head. The rest of you have a much easier to use calculator than Audrey, bless her heart, and her calculator. However, she's going to be fine. All right, question.
Can you show how to find circumference if it's radius?
Well, considering the formula C equals 2 pi r, you'd have to do 2 times pi times the radius, right?
So it's 8 questions, not full, like 4.
There's 8 of them.
It looks like there's...
No, there's 8 of them. There's a top row and a second.
Okay.
All right, so you just multiply the radius times 2. That's what I would do. I would do radius times 2 to get a diameter, and then multiply that by pi. All right, practice exercise 88. 2 decimal places. Don't forget your units. Use the pi button, not 3.14 because it's not as exact. Go. for sake of time, stop where you're at, see how you did on the ones you got done, but hopefully starting to feel a little bit more comfortable with the calculator. Ethan was first. Ethan, as we go across the top row, a diameter of 4 feet gives us a circumference of
12.57 feet.
12.57 feet. Radius of 6.5 meters.
40.84 meters.
40.84 meters. Again, these are approximate answers. 17-foot radius.
106.81 feet.
106.81 feet, and a diameter of 6 inches.
18.85 inches.
18.85 inches is correct. Going across the next row, we have a radius of 2.5 or 2.5 yards. We get a circumference of
15.71 yards.
Though when you multiply by 2, it comes to an even 5 anyway, so we don't really have to worry too much about that fraction. 15.71 yards, diameter of 12.9 centimeters.
40.53 centimeters.
Good. 40.53 centimeters. The next one.
11.00 kilometers.
And it is important to write the 0.00 because it didn't come out evenly to 11. It just happened around to both zeros. So yes, 11.00 kilometers. And the last one?
43.98 feet.
43.98 feet is correct. Republican or Democrat?
Republican.
All right, because we're going to do another one. So I gave him a choice of red or blue. This next one's for the blue raspberry. The next one we're going to work on, by the way, before we do, how many got all the ones you did correct? All right, how many did you miss?
2.
2 of them. Was it that you maybe forgot to double a radius, or do you think it was something to do with the calculator that was messing you up?
I don't know.
Which ones did you miss? Give me one of the ones you missed.
2.
Number 2, what did you get for your answer?
428.30.
428. I think you probably entered 65 instead of 6.5. You said 428, correct?
128.
128? That wouldn't be right then. No. Not sure what you did then. Go and redo it on your calculator. 2 times that radius times pi. And then we'll go on to the next exercise here in just a moment.
40.84.
There we go. Okay, so we got it now. All right, the next one is to find an area of a circle. And for the area of a circle, it's in the text there, but reminds you that area formula is pi r squared. Now here that means you're going to have to start by squaring the radius. But what if they gave you a diameter?
Radius 2 feet.
You'd have to cut the diameter in half. So given a diameter, divide it by 2 to give you the radius, then you would square it. To square something on the calculator, I believe you've done this before in Algebra 2, but some of you who haven't had Algebra 2 yet, this might be new for you. It should be right here, a couple above the 8, right? Almost toward the middle of the calculator, the x squared button. So for instance, if I gave you a radius of 17 centimeters, you just type the 17 on the calculator and hit squared. And your calculator shows 289. Once you've got the r squared times pi equals. And of course, if you've got the fix on, 907.92 centimeters squared, because area is always in square units. How many of you were able to follow along with me on entering this? Squaring the radius, multiplying by pi. Were you able to? Okay, so you're good to go on your calculator there. Still don't know how to do the fix on your calculator, not sure if it's able to. The rest of you were good on the fix, we're good on pi, we're good on squared. All right, and again, if I gave you a diameter, for instance, diameter, we'd have to take the 17, divide it by 2 first. That gives the 8.5, then square it, 72.25 times pi, 226.98. Okay, questions on that? Exercise 89, go. And for those who can remember slaving over problems like this in junior high, this has to feel really good right now. All right, for sake of time, did you finish? For sake of time, let's go ahead and take a look at these together. And again, squaring dawned on me while I was watching your work. They should be good with squaring. We do it in Pythagorean Theorem, don't we? We have to use the squared feature on the calculator. All right, first was Quentin this time. Quentin, round to the nearest hundredth, finding the area. If the diameter is 4 feet, the area is?
12.57 square feet.
Good, 12.57 square feet, or feet squared. If the radius is 6.5 meters, then the area would be?
132.73 meters squared.
Good, 132.73 meters squared. Now, quick technicality reminder, metric units like meters are always units squared, never square units. We wouldn't say square meters, we would say meters squared. Just a weird thing about metric or SI units. The next one, 17-foot radius. Oops, I think I had that one up there a minute ago.
907.92 square feet.
907.92 square feet, except I think I had centimeters, but yeah, oops. All right, diameter of 6 inches.
28.27 square inches.
Good, 28.27 square inches. Going across the bottom row.
19.63 square yards.
Good, 19.63 yards squared. The next one?
130.70 square centimeters squared.
Right, 130.70 centimeters squared. The next one?
9.62 kilometers squared.
Good, 9.62 kilometers squared. And for the last one?
153.94 square feet.
Good, 153.94 square feet. Great job on that. Did you missed one?
I missed one. I forgot.
All right, anyone get all the ones you did correct, even if you didn't finish?
I got them all right.
You missed.
I just missed. I skipped one.
Skipped one somehow. Question.
Missed all the diameter ones.
Missed all the diameter ones. You divide by 2. So, for instance, Chris, let's do the second one on the bottom row. We were given a diameter of 12.9 centimeters. Well, that's a diameter. If I want to get a radius, we know a radius is half, so divide by 2 on your calculator. What do you get?
6.45.
All right, now while that's on the calculator, remembering that the formula is a equals pi r squared, go ahead and square the number on the calculator.
41.60.
Right, now multiply that, that's r squared, times the pi.
130.70.
There we go. That's it. So just divide by 2, then square, then times pi. Of course, you've got the fix on, so it's already rounded. All right, go and pass those in if you would, please. Now let's quickly review some of our most recent pictures and quote-unquote proportions. They don't all actually involve proportions. For instance, the first picture that you see is simply a right triangle. 2 sides indicated as being known, 1 side is being indicated as unknown. Well, we don't use a proportion for that, but anytime we have a right triangle, and we know 2 sides, and we want the third side, how would I find that third side, Jamie?
The Pythagorean Theorem.
Good, the Pythagorean Theorem. And what is the Pythagorean Theorem, class? C squared equals A squared plus B squared. Where it's important to remember A and B have to be the legs, C is the hypotenuse. So if I'm finding a leg, I'm going to have to move the other squared leg over as a negative, or subtract it away, remember. And of course, don't forget to take the square root at the end. This picture is also a right triangle. One could argue, if you know 2 sides and want to know the third side, you could still use Pythagorean Theorem. But there's an altitude drawn, which makes another little right triangle. One could argue, if you know 2 sides and want the third side, you could use Pythagorean Theorem. Or if you knew 2 sides and wanted to find the third side of this right triangle, you could use the Pythagorean Theorem. Or, if it weren't necessarily sides of those triangles specifically that you wanted, we have a couple of proportions we could use here. Chris, give us one of them.
Segment to leg is leg is to hypotenuse.
Good. Segment is to leg is to hypotenuse. Of course, we could do it this way as well. Segment is to leg is to hypotenuse. Or the other proportion in words, Audrey. There we go. Segment is to altitude is to that other segment. Again, this picture, they are mean proportionals. Okay? This next thing doesn't use a proportion either. What's true about this picture? We've got a couple of intersecting chords, Ethan. This is what we practiced with, I think, 3 or 4 problems in the homework last night.
Right.
Quentin? It's not a proportion.
Yeah.
One side of the line plus the or times the other side of the line equals one side, the other line times the other side of the line.
Good. Segment times segment equals segment times segment. In other words, product of segments equals product of segments. Say that with me, class. Product of segments equals product of segments. Multiply two together, that equals the other two multiplied together. And that's what we would have in this picture. And then here, when we've got two lines drawn to a circle from an external point, one of which is tangent, one of which is a secant, Ethan wants some redemption here. What's our proportion for this picture?
Secant is tangent is an external segment.
Could another mean proportional? Secant, the whole thing, is to tangent. And of course, that would be this whole thing, as tangent is to just the external segment of the secant. And we also had a few problems like that for homework last night. Take your books out. Turn to page 213. You did numbers 1 through 7. Page 213, you did 1 through 7 for homework last night. Let's take a look at those together. And number 1, and looks like 1 through 4, we're using the picture from Theorem 63. So looking back across the page, we were given a circle, circle O. We were given a chord, AB. And we were given an intersecting chord, CD, and they intersected at this point P. So this is the picture we're basing everything off of. Then it says if PB is 2, if AP is 9, if PD is 3, find CP. Well, maybe we'll call it X. How do I set up the problem here? Ethan?
3x equals 18.
Good, 3x equals 9 times 2, or in other words, 18. So obviously x equals 6 and good inches, since they had a unit there. How many had 6 inches for CP in number 1? Excellent. Let's take a look at number 2. Same picture, different information. It says that AP is to PB as 4 is to 3. They tell us that PD is 6 inches and CP is 8 inches, but AP is to BP as 4 is to 3. Genesis? That doesn't, I mean, they're not 4 and 3. How do I represent them if they're in ratio 4 to 3?
4 to 3.
Well, they're in ratio 4 to 3. AP to BP is a ratio 4 to 3. Kendall? 4x and 3x. Remember, anytime things are in ratio, just stick x's onto the ratio values and there you've got it. So, how would I set up the problem? Back to Genesis.
4x
Is to product equals product. So 4x
times 3x equals 6 times 8.
There we go. Of course, 4x times 3x, be careful, is good, 12x squared. Easy mistake for geometry students to make, having forgotten some algebra, to just say 12x. But 12x squared equals 48. Of course, to get the x by itself, we first need to divide away the
12.
To get x squared is equal to 4, but we don't want x squared, we want x. So we'll take the square root of both sides to get x is equal to. Technically positive negative 2, but we don't really want positive negative, we just want the positive. So if AP is 4x and x is 2, then AP must be 4 times 2? 8. And then if BP is 3x, of course x is 2, then BP is 6. Interesting. What does that mean about my chords, class?
They're bisecting.
They're not bisecting.
They're equal.
They're equal to each other, right? They're both equal, which means they're equidistant from the center. And so, yeah, so each chord is split into segments of 8 and 6, respectively.
It also means they what's it called? They bisect each other. It doesn't, or not bisect.
They are not bisecting.
Perpendicular.
We don't necessarily know that they're even perpendicular per se.
Oh.
We just know that they're equal chords, which means they would be equidistant from the center. All right, number 3 is a little bit different. Same idea, but we're going to modify the picture slightly because it tells me that the chord AB is actually a diameter this time. So when we draw our AB, we have to draw it as a diameter. And then it says P is some point on AB such that AP is 3 inches and BP, this whole segment here, is 12 inches. Then it says find the length of the chord perpendicular to AB at P. Find the length of the chord perpendicular to AB at P. What do we know about a diameter or radius that is perpendicular to a chord? Chris?
Right angle?
Well, yes, of course, right angle, but we also know
Bisects?
it bisects. Here not, but a diameter or radius perpendicular chord does, which means if it bisects, then each of these pieces, class, must be
Same, equal.
equal, which means I could represent both of these unknowns as x. And although it looks a little different, it still is two intersecting chords, is it not? One of them happens to be a diameter, they're happening to be perpendicular, but they're still two intersecting chords, which means product of segments equals product of segments, which means, Audrey, good, 3 times 12 equals x times x, or x squared. Of course, 3 times 12 is 36, and if that equals x squared, take the square root, x just equals 6, which means each of these pieces must be 6 inches. Question, if each of those pieces is 6 inches, what is the length of the chord, class?
12 inches.
12 inches, and there's our answer. How many had that for this problem? Those who didn't, does it make sense now? Does it make sense now? Any questions? All right. Let us take a, by the way, what's the radius of this circle? I didn't ask, but just throw the thought out there. What's the radius of the circle?
It'd be 9.
7.5.
7.5. How do we get that? Well, what's the length of the diameter, class?
15.
15.
Divided by 2.
Half the diameter would be 7.5. Way to think outside the numbers you were seeing here and put it all together. Good, Quentin. Let's see, number 4. It says find the length of the shortest chord through a point 5 inches from the center of a circle whose radius is 13 inches. Okay, this one a little bit more challenge to figure this out. So let's start with a circle, and it tells us that the radius of my circle is 13 inches, correct? That means, by the way, if I were to extend this out to a diameter, the diameter would be 26 inches, right? Because here we have another 13-inch radius. Then it says we've got a point that is 5 inches from the center. So here's my center. Now, I could pick any point 5 inches away, right? But I could draw the same radii or diameter through it. So I'm going to pick 5 inches away here. So right here, 5 inches, and I've got a chord. Now, there's an infinite number of chords that can be drawn through that point, correct? But the shortest chord that may be drawn would be the perpendicular. Think about it. If you drew a slanty chord through it, the slanty chord is closer to the center than 5 inches, isn't it? And the closer you get to the center, the bigger the chord. The smallest chord has to be perpendicular, so you have a full distance of 5 inches. And if you have a radius or diameter perpendicular to a chord, it bisects the chord. So once again, each segment of the chord could be called x. And once again, yes, one of these is a diameter as drawn, but these are still intersecting chords, so we can still say that product of segments equals product of segments. Now this product, of course, is x times x, class, x squared. But what are these segments here?
13 and then 7? Or 8?
This one's 8, because we took 13 and cut 5 off of it.
And 18?
18. We have 13 and we gave 5 more to it. So x squared equals 8 times 18 on your calculators. What do we get?
144.
And we can do this in our head. What is x? 12. So each of these pieces is 12 inches. But what's the length of this chord, class? 24 inches. I'm assuming based on responses nobody got that.
No.
Does it make sense how to think it through now? Questions on that? All right, well, let's change gears as we come to number 5. And here we're using the picture from Theorem 64, and that is the tangent and secant. What's that proportion again, class? Secant is to tangent as tangent is to external segment. All right, so referring to the picture at the top of the page now, we've got this secant, A BP, and then from P we've got this tangent line PT. By the way, a question for you. You notice in the little sketch they've got these little line thingies here, right? Could this line here, AT, ever be a diameter?
Possibly.
Could that line ever go through the center of the circle?
Yes.
Sure, why not? For instance, if P had been here, and yeah, absolutely. Okay. Could erasing some of the extra lines to get them out of the way here. Could TB ever be a diameter?
No, it's not long enough.
Well, I mean, you know, if we just shifted B up here now and
Oh yeah, then it could be. Yeah.
P through.
No,
If you put P on the other side, maybe.
Well, if P was up here,
no, it's not possible.
no, why not? Because if B, the first point of intersection, were over here on the circle, then this would no longer be a secant, it would be a tangent at the ends of a diameter. What do we know about tangents at the ends of a diameter?
They're equal to the difference of arrows.
They're parallel. So in that case, you couldn't have them drawn from the same point anyway. So anyway, just some quick thoughts there on the picture. They were in the think it through section. Thought I'd throw those thoughts out there. Let me get the picture back the way it's supposed to be. So we had P, B, A, P, T. All right, so number 5. We were told that PA, the whole thing was 18. We were told that PB, the external segment, was 8, and we were asked for PT. Again, class, the proportion is secant is to tangent is to external segment. So Jamie, how do I set up the proportion?
You have 18 is to x is to 8.
Good, 18 is to x is to 8. And this is going to look strangely familiar. When we cross multiply, we get x squared equals 144. Remember doing this just a second ago? Yeah. So we end up getting x's class. 12 or negative 12, but of course we'll simply say 12. And is it inches again? Yep, 12 inches. They are painfully predictable. How many got 12 inches for PT?
Nice.
Excellent, good. Should have been all of you. Number 6 says that PT is now 24 inches, so we'll modify our numbers here. PB is 16 inches, and it says to find PA. Well, again, secant is to tangent is to external segment. Genesis, how do I set up the proportion?
X plus 16
X plus.
minus.
Secant is to tangent as, okay, sorry. We're finding PA. Now I could call this piece here X, and then this would be X plus 16. I'm sorry, my brain was filling in something else. But then the hard part though, Genesis, is I don't care about AB, so why would I call this X? Does that make sense? Doesn't mean it's wrong though. Let's do it your way. X plus 16 is to,
24.
as
24.
is to, and of course you see here the cross multiplication becomes, like if this were just plain old X, it becomes a lot easier, no distribution. But it's not that we can't do it this way. Genesis, assuming this is what you had, what did you have in your work?
16 plus 32.
Oh, careful. That'd be 16 plus 16. We need 16 squared or 16 times 16, anyone? 256. Good. And then is equal to, well, 24 squared, algebra people? Actually, she has that already. 576. And so from here then, instead of subtracting the 32, we should have subtracted the 256. Somebody get that for me? 320. And then that would equal 16x. And we'd have to divide away the 16 from both sides to get x equal to 20, which is AB. We wanted AP, so that's going to be the 20 plus the 16, which would have given us class 36. Again, it would have been much easier to do this had we just called PAX. But, Genesis, in your defense, we worked a lot of problems yesterday where we wanted AB. And so we had ended up calling this x and x plus 16. And again, as long as you don't forget to finish, of course, distribution error hurt a little bit, but as long as you finish it out, should be good to go. How many got the 36 regardless of how you did it? How many did it the way Genesis did, just with correct distribution? Okay, several of you. You were certainly not alone in the x plus 16 up there. Do all of you see, since we don't care about AB in this particular problem, man, it would have been a lot quicker with just the x right there. Hey, question?
Can you work out the other way?
Yeah, absolutely. If this were just x, you don't even care about this. Secant is to tangent as tangent is to external segment.
That's the way I
16x equals 576. Divide away the 16 from both sides. X equals 36.
That's what I did.
Yeah, a lot easier to do, but yeah. Right. She did not.
I said we. I said
Oh, we
I did
wasted
I did the
that.
same
Okay.
thing.
All right, questions on 6. Let's go to number 7, and this one changes things just a little bit because it says that PBA passes through the center of the circle. All right, so we're gonna have to redraw this picture just a little bit, and so here's A, B, P. And we've got our tangent line drawn there, so we'll call this T. And it says that PT is 8 feet, PB is 4 feet, and it says find the radius of the circle. If PT is 8 feet, PB is 4 feet. So what I want to know is that. Couple ways we could set things up here. We could do what we did last time. How many called ABX and PAX plus 4? Anyone call the whole thing PAX, and then we'll go ahead and subtract the 4 and divide. I don't do all that. There's a couple of you did that as well. Again, I lean toward making the proportion easy. I lean toward just calling the whole thing PAX, because I don't know the secant. So secant I don't know is to tangent, as tangent is to external segment. 4x equals 64, x equals 16. Now here's the deal. That means this is 16. Which means if this is 4 out here, this is 12. Which means this is 6. 6 feet is our answer. That's one way to set it up. The other way is, as I showed a moment ago with the purple writing, is to go ahead and say secant x plus 4 is to tangent 8, as tangent 8 is to external segment 4. Again, be careful in the distribution here, Genesis, for redemption. There we go, equals. We'll subtract the 16 from both sides to get 4x is equal to. Use your calculator if you have to. 48, and then divide both sides by 40, x equals. Remembering that 12 is the diameter, so the radius is still, either way you work it, 6 feet. How many got 6 foot radius for the circle? Several of you. Questions from those who did not.
I got 12, but I forgot to put it in.
You got the diameter, forgot to cut it in half to get the radius. Okay. Questions? Genesis, did you get 16?
I distributed wrong.
Distributed wrong. Okay, so a quick refresher on the distribution then. Any questions at all on these pictures? All right, clear desk except for a clean sheet of paper and a pencil and a calculator. Clean sheet of paper, pencil, and calculator. First and last name at the top of your paper along with today's date. First and last name at the top of your paper along with today's date. Today is 4/2/21. 4/2/21. And this is quiz 34B. So if you look at the quiz, it actually just says quiz 34, but it's really quiz 34B. All right, fairly straightforward. You've got 4 pictures, 1 through 3. Use the first picture. They're all connected together, okay, so it's not separate problems. They kind of build on each other for 1, 2, and 3. 4 and 5, they are separate problems from each other, but you're going to use the second picture. 6 and 7, they are separate problems, but you're going to use the third picture. 8 and 9, separate problems, but they both use the fourth picture. And there's a bonus for you dealing with the first picture. Do not write on the quiz copy. Copy the pictures over onto your own paper as you work. All right, you may begin. There will be no homework this evening, and I'll end the video here.